Students, so in this class let us solve a problem on Dijkstra's algorithm. Okay, look at the question. Using Dijkstra's algorithm, we have to obtain the shortest path from the vertex 0 to each of the other vertices in the weighted network diagram as shown below. Indicates the weight of this shortest path. So this is the given weighted graph, right? So here you can see that these are the vertices. So 0, 1 and 2, 3 and 4 and 5 and 6. These are the vertices. So now we need to find the shortest path from the vertex 0. So we can say that the vertex 0 is what? The vertex 0 is known as the source vertex, right? I can say that this is 0 as what? It is the source vertex, right? Right. Now, so we need to assign permanent weight and temporary weight to the vertices. So we have a weighted graph, we have a non-negative quantity assigned to each edge here. Now we have to assign weights to vertices. So in the very first iteration, we have to assign permanent weight to the source vertex and temporary weights to the other vertices. We can see that here, let me assign the permanent weight to the source vertex as 0 and the other vertices as infinity. Okay, so in the first iteration, so I will assign weights to the vertices, right? So in the first iteration, I assigned, let me consider this as 0, 1, 2, 3, 4, 5 and 6, right? In the first iteration, we assigned 0 to the 0 vertex since it is the source vertex, and we assigned infinity to other vertices, right? So among these numbers, which one is minimum? 0 is minimum, and that corresponds to 0. So let me write 0 here, right? So this will be done in the first iteration. Now let me consider the second iteration. Now we have to fix this 0 here. Okay, let us block this 0. This corresponds to 0. Let us block this 0 now. Now look at the vertices which are adjacent to 0, right? So it is we have 1 as well as 2. We can say that the permanent weight of the vertex 0 is 0. So 0 plus 2 is 2. Among 2 and infinity, we should consider the minimum 1, 2. Here 0 plus 6 is 6. We have infinity. So among 6 and infinity, we have to choose 6. Right? So in the second iteration, we have allocated the weight to the vertices 1 as well as 2. Right? What happens in the second iteration? So here 0 is fixed throughout. Okay, don't write that again. And for the vertex 1, we assigned the weight as 2, and for the vertex 2 we assigned 6, and the remaining is having infinity. And among 2 and 6, which one is minimum? 2 is minimum, and that corresponds to 1, so write 1 here, right? Now let us block the vertex 1. Where is the vertex 1? Here is the vertex 1. Let us block this, right? Now look at the vertices which are adjacent to 1, right? We have 0 as well as 3. 0 is already blocked, so just leave that as it is, and here we fixed 2 here, right? So don't allocate anything to that. Now consider the vertices which are adjacent to 1, that is 3 only, right? 0 is blocked already, so we have 2 plus 5 is 7. Among 7 and infinity, we have to allocate 7, the minimum quantity, right? And that's the only possibility. So we allocated 7 to the vertex 3. So for the vertex 3, we allocated 7, and 6 is carried as it is, and this infinity is also carried as it is. So among 6 and 7, which one is minimum? 6 is minimum, right? And that corresponds to 2. So now we have to block the vertex 2, right? We have to block this vertex 2. Now we have to look at the vertices which are adjacent to 2. So 6 plus 8 is 14, right? Here we have 6 plus 8 is 14, and there is already 7 is allocated among 6 and among 14 and 7. So among here look at the vertex 2, right? Fine. So here we have to block this 2 now, right? We have to block this 2. So here this is the vertex 2, and we have the only one vertex which are adjacent to 2 is 3, and 0 is already blocked here. So 6 plus 8 is 14, but for the vertex 3 we already allocated 7. So among 7 and 14 we should choose the minimum one, so leave that as it is. Okay, so don't allocate 14 there, because 7 is already allocated there, 7, and the remaining is infinity as it is, right? So among these three numbers, 7 is the minimum one, and that corresponds to 3. So write 3 here. Now let us block 3. Right? So we have 7 here for the vertex 3. So look at the vertices which are adjacent to 3. That is 5 as well as 4. So 7 plus 15, which is 22. And 7 plus 10, which is 17. Right? So now in this iteration we allocated 22 to the vertex of 5, and we allocated 17 to the vertex 4. This is already blocked here, right? Infinity is carried as it is. So among 17 and 22, 17 is minimum one, and that corresponds to 4, right? That 4 here. Now we have to block 4 now. So now look at the vertices which are adjacent to 4. We have 3 vertices, 3, 5 and 6. Among these 3 vertices, 3 is already blocked, so we have to consider 5 as well as 6. So 17 plus 6, which is 23, but we already allocated 22 here. So among 22 and 23, 22 is the minimum one, so leave it as it is. And 17 plus 2 is 19. We have infinity, so let us allocate 19 there, because 19 is a smaller value, right, than infinity. So now let us do the allocation. In this iteration we allocated 22, so 22 is carried as it is, and we allocated 19 to the vertex 6. Among 22 and 19, 19 is the minimum one, and that corresponds to 6. Now let us block 6 here, right? So we have 19, so 19 plus 6, which is 25, but we already allocated 22. Among 22 and 25, 22 is the minimum one, so leave that as it is. So for the vertex 5 we have 22, right? So from this weighted matrix we can say that the distance from the shortest distance weightage required from 0 to 0 is 0, and from the vertex 1 to from the vertex 0 to vertex 1, which is 2 weights are required, and from the vertex 0 to vertex 2, 6 weightage is required, and from vertex 0 to vertex 3, 7 weightage is required, and from the vertex 0 to vertex 4, 17, the minimum the shortest distance weightage 17 is required, and from the vertex 0 to vertex 6, 19 weightage is required, and from the vertex 0 to vertex 5, the shortest path weightage is 22, right? So now let us consider the path now. Okay, let us consider the path. So 0 is the source vertex, 0 to 1, and 0 to 2, and we have 0 to 3, and 0 to 4, 0 to 5, and 0 to 6, right? So these are the paths, and we have to choose the minimum path for this, that is the shortest path, right? Okay, so from 0 to 1, the minimum shortest path weightage must be 2, right? So you have to choose a shortest path like that, right? Okay, so look at the figure here. From 0 to 1, we can go like this, right? So we can start here and we can go like this, right? We can choose this. We can choose this. This is the shortest path. We can go from 0 to 1, right? From this path also, but we have to choose the minimum path, the shortest path. So the shortest path is what? 0 to 1, whereas the minimum path weightage is 2, which is satisfies here. And from the vertex 0 to vertex 2, the shortest path weightage is 6. 6 is required. So 0 to 2. So here we can say that 0 to 2. So we can go directly from 0 to 2, right? If we go like this, the weightage will be more. That cannot be the shortest path. So this is the shortest path. So it is what? It is 0 to 2, and the weightage is what? 6, and that satisfies this, right? And from 0 to 3, the shortest path weightage must be 7. So here this is 0 and this is 3. So either we can go like this, so 0 to 1 and 1 to 3, that is 2 plus 5 7, or we can go like this, 0 to 2 and 2 to 3, so 6 plus 8 14. But here 2 plus 5 7, so this is the minimum path, so we have to choose this, right? 0 to 1 and 1 to 2, which is 0 to 1 and 1 to 2. 0 to 1, the weightage is 2, and 1 to 2, the weightage is 5. The total weightage is 7. That satisfies this. Now, from 0 to 4, the minimum shortest path weightage required is 17. 0 to 4. This is 0 and this is 4, right? So either we can go like this. So 0 to 2, 2 to 3, and 3 to 14. 3 to 4. So in this case, 6 plus 8 is 14, 14 plus 10, 24. We can also go like this, 0 to 1 and 1 to 3 and 3 to 4. It is 2 plus 5 7, 7 plus 10 70. So this is the shortest path, right? So how can we able to do that? So 0 to 1 and 1 to 3 and 3 to 4. So 0 to 1, which is 2, 1 to 3, which is 5, and 3 to 4, which is 10. So it is 10 plus 5 plus 2, which is 17. Now from 0 to 6, the shortest path weightage must be 19. So how can we go from 0 to 6? So this is 6, right? So 0 to 1, 1 to 3, and 3 to 4, and 4 to 6. That is the shortest path weight here, right? So here we can say that 0 to 1, 1 to 3, 1 to 3, and 3 to 4, and 4 to 6. So 0 to 1, the shortest path weightage is 2. 1 to 3, the shortest path weightage is 5, and 3 to 4, the weight is 10, and 4 to 6, the weightage is 2. So it is 12, 14, and 19. So it satisfies this condition. And from 0 to 0 to this is 0 to 6. From 0 to 5, so we required 22 weightage here. 0 to 5, this is 5, right? So we have to go like this, 0 to 1, 1 to 3, and 3 to 5. 0 to 1, 1 to 3, and 3 to 5. So 0 to 1 is 2, and 1 to 3 is 5, and 3 to 5 is 15, right? Or you can go like this, 0 to 2, 2 to 3, and 3 to, that will be even more, right? So this is the shortest pathway. So and here 15 plus 5 20, 20 plus 2 22, etc. Right? So in this way we can able to find the shortest path weightage. Shortest paths in this manner we can able to find the shortest path from the source vertex to other vertices in the given graph.